Hi, Mitch Bailey here, with Bailey's Heating and Air Heroes. Let's talk about BTUs and tonnage. So what is BTUs? And you hear us refer to tonnage also whenever we're talking, and sometimes when we're talking to the customer, we don't realize it that because it's our lingo that may not understand. Is that unit really weigh 3 tons? Does it really weigh 6,000 pounds? No. So we're going to have to start. We start with BTUs. So BTU is a measure of heat energy. More importantly, it's the amount of energy that it takes to raise 1 pound of water, or H2O, 1 degree Fahrenheit. So if I was to raise a pound of water 1 degree Fahrenheit, that equates to 1 is equal to 1 BTU. To kind of give you an idea of how much energy that actually is, if you took a large kitchen match and you lit that match on fire, and if you light that match on fire and it burns all the way down, a large kitchen match would produce approximately 1 BTU. In other words, it would raise 1 pound of water 1 BTU. So that's a BTU, and when we're talking about energy, we talk about tonnage because BTUs, we deal in a lot of BTUs, and so it's like a 3-ton unit is 36,000 BTUs. So it's easier to refer to it in tons. But why do we use tons? Well, in the old days, you had an ice box, and the ice box, it had your food or perishables were inside the ice box, and above it was a place to put or store a block of ice. And that block of ice, as it melted, would absorb heat out of the ice box, and it would absorb that heat. So, this is a simple thermodynamics. So for every pound, 1 pound of ice, frozen H2O, it will absorb 144 BTUs. And that's the nice part about it, because we get, it takes 1 degree to raise it or lower it 1 degree, it takes 1 BTU. But as it changes from a liquid to a vapor, as it changes state is what we refer to it. As it changes from a solid to a liquid, in this case ice, it'll absorb 144 BTUs. So they did the math. They said, look, okay, if we took a ton of ice, 1 ton of ice, or 2,000 pounds of ice, and we melted that ice over 24 hours, how much energy would it absorb? Well, if you do the math, it's 2,000 BTUs, or 2,000 pounds, times 144 BTUs per pound, and we come up with 288,000 BTUs. Now, if we want to know how much we actually use in an hour, so they divide that by 24, take the 288,000 and divide it by 24, and we come up with 12,000 BTUs per hour. And that's how we come up with a ton. That equates to a ton of cooling, is the amount of energy it takes to dissolve or to melt 2,000 pounds of ice over 24 hours. And then we just use this hour figure, so we're saying in an hour it's 12,000 BTUs. So if we had a 3-ton air conditioner, and so if we had a 3-ton air conditioner, 3 tons is equal to 12,000 times 3, which is equal to 36,000 BTUs per hour. And if you have, let's say, a 2.5 ton, because they come in half-ton, that would equal to 12,000 BTUs per hour times 2.5, which is equal to 30,000 BTUs. So half a ton is 6,000 BTUs, and 1 ton is 12,000 BTUs. That's BTUs per hour for both of these. Very simple, easy to understand. So if we're talking this lingo to you in the future, and you hear a guy saying, yeah, it's a 3-ton or 2.5 ton, you'll know that it doesn't weigh 3 tons or 6,000 pounds, that it's actually 36,000 BTUs the unit should be producing. So thanks for listening.